Geometry lesson 6-7. Spent a lot of time dealing with quadrilaterals, parallelograms, and a bunch of different shapes. And today we're going to take it a little bit further, but we're going to talk about some other special shapes and maybe how we can find some area of them. So our first thing we'll look at right now, this example, is we want to find the area of this triangle. Now most times when people are looking at the area of a triangle, they aren't dealing with an obtuse triangle like this, so they're not quite sure what they should do to take care of it. All area formulas for a triangle, the area is equal to 1/2 the base times the height. Now the key is, with base and height, they have to be coming together at 90 degrees. So typically what happens is people make mistakes dealing with this. They're like, I don't know what's my height and what's my base. And they think that this is the base, which is good. That is the base. But they think that this value right here is the height. And that's where they make the mistake. In reality, whatever this measurement is right here is the height of the triangle. That's as tall as it gets anywhere. It's the highest point, right? But if I were to have it there, that's the height of the triangle itself. It's still going to be 90 degrees with the base. So that's really important that you understand you're looking for the height of this triangle, which means it has to be coming in at 90. It must form a 90-degree angle with where the base would be. Now, I don't care about this little section here. I'm not going to add that on to the 4. The base is still 4. The height is 3. And that's really important. So now when you go to find out what you're doing, you have a 4. Oops, I didn't mean to move that. You have a 4 that you stick in for the base, and you have a height of 3. Now solving simple. A is equal to 1/2 the base of 4 and the height of 3. So A is equal to 1/2 times 12, which means that the area is 6 units squared. And the reason I'm saying units is because I don't know if these are inches, feet, miles, centimeters, so I just say units. But it needs to be squared if it's an area. Alright, next one. Rewrite the area of a triangle in terms of B. Now, rewriting means to play the shuffling game. Okay, so we want to shuffle. Move stuff around. Area of a triangle is 1/2 the base times the height. Right now, the area formula is written in terms of A. It means that A is alone. So in terms of B, means get B alone. That's what we need to do in terms of B. That's okay. So we'll take our equation. And the first thing we'll do is get rid of the half by multiplying by 2 over 1. Multiply this side by 2. That means that 2 cancels and those 1's cancel, and you got 2A is equal to B times H. All you got to do is move that H, and B is now all alone. Divide by H, divide by H, and there it is. 2A over H is equal to B. Rewritten in terms of B. Why would you want to do this? Well, maybe you have a situation where you don't know the base, but you know lots of different triangles that have area and height, and so you're trying to figure out what would the base of them be. It's easier to reshuffle the program or the formula first, and then you have something you can just plug in answers for or numbers for A and H, and out pops your answer of B. All right, sticking with the area formula, now we have a trapezoid. So the trapezoid, what you have to do is that you add the bases together. It doesn't matter which one you refer to as base 1 or base 2, because you're going to add them together anyway, and the commutative property of addition states that order doesn't matter. You're going to multiply that by H, which is the height. Again, the height and the base come together at 90 degrees, same concept as a triangle, and then you take that answer and you cut it in half. All right? Cut it in half. So, if we had 10 here and we had, or 20 here and 10 here, you would add the 10 and the 20 together to get 30. Say the height was 5, you'd go 30 times 5 is 150, and then you'd cut that in half and you'd say the total area is 75 units squared. Again, they have to be squared. Alright? Kites. You can find the area of a kite by taking the 2 diagonals and multiplying them together and then cutting that in half. Alright? So this is one diagonal right here. That's that diagonal. And this is the other diagonal right there. So you take those 2 diagonals and you multiply them together. Right? But if you were to do that, that would give you more area than the kite, so you have to cut it in half. So let's look at it in pieces. All right, here is the the same kite. So if I have my value, you can see it was in there. And as I progress and I plug those values in, now taking the pieces apart, notice that this kite looks pretty similar to this one down here. Okay? I know it's a little bit on the mend here, but there's your triangle. All right? And I want this particular, let's ungroup it. Okay, there. Now as you look at it, you can see that the exact same pieces, this piece is the same as that piece, this piece is the same as that piece, this piece is the same as that piece, and that piece is the same as here. And if I were to move these values, like this part down there and that part down there, and you multiplied the red together, you would end up with a rectangle. And that rectangle is this entire amount. But you don't want the entire amount. You only want half of it. And that's why it has to be cut in half. So that's where they come from. That's where the formula comes from. The idea that this value is the side of the rectangle, and this value here is the other side of the rectangle. And when you multiply the two sides together, you get the area of the entire rectangle, but you only want half of the amount that's in there. Alright? Basically the exact same idea for a rhombus. The two diagonals. So here's one diagonal inside, here's the other diagonal here. You multiply the two, and that would give you the area of this entire rectangle. But you don't want all the rectangle. You only want half of it. Half of that, half of that, half of this, and half of that. Half of the entire thing. So it's the same formula for a rhombus as it is a kite. They share the same formula, which is nice. You only have to remember the one. So let's try it out on this problem. Find the area of the kite, ABCD. We know that this entire distance is 16 plus 8, which makes 24 for this distance. And we know that 8 and 8, which is the distance across, is 16. So we have area equals 1/2 times 24 times 16. It doesn't matter which half you multiply by. For me, I'm going to do this. And I'm going to say A is equal to 24 times 8. And the reason? Because I can multiply 8 times 20 in my head, and I can multiply 8 times 4 in my head, and then add the two together. So 8 times 20 is 160, and 8 times 4 is 32. If I add 160 and 32 together, I get 192 units squared. And that's the area. Again, it doesn't matter where you multiply by 1/2. I could have multiplied 1/2 times 24 and got 12, but then I have to multiply 12 times 16 in my head. I could have multiplied 24 times 16 first and then multiplied by 1/2. It won't matter, but in the end, I have 192 inches squared. In our last example, let's find the area of this very odd, peculiar shape. There's a number of ways you can do it. One method is you could go across like this and realize you have a trapezoid on top of a rectangle. And that would work. You can certainly do that. Another method is some people add on these triangles, and then they're dealing with a big rectangle, and then they subtract those triangles on the end. It doesn't matter. It's up to you. If you would rather cut them off this way and you have a trapezoid on that end and a trapezoid on that end, that's fine too. There's a lot of ways you can do it. It's really up to you. For me, I'm going to go ahead and take the trapezoid at the top and add it on to this rectangle down below. So down below I have 8 times 16. So the units down here are inches. 8 times 10 is 80. 8 times 6 is 48. 80 and 48 is 128 inches squared. That represents the rectangle. Now the trapezoid is going to be area equals 1/2. The height of the trapezoid is 3 inches times the bases put together. Now this base is 10 inches, and here's another 3 and a 3, but basically that line is the same length as the 16 down here. So I have 10 plus 16, which means area equals 1/2 times 3 times 26. Now, I'm not going to multiply 1/2 times 3 because that's going to give me a decimal. I'm going to multiply 1/2 times 26 because I can multiply in any order I want. A equals 3 times 13. And I can do that in my head A equals 3 times 10 is 30, 3 times 3 is 9, so 39 inches squared. That represents the trapezoid. To find the total area, I've got to put the two together. So 39 to 128, 128 plus 39, 7, carry it, gives me 6, 167 inches squared. That's the area, the total area of this entire shape. And it can be found in multiple different ways, just depends on how you cut up the overall shape itself.